Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is AA-1, a basic introduction to angles. Okay, we're going to be using a protractor to measure a variety of different kinds of angles, and then we're going to, based on the measurement of the angle, we're going to name each of these angles. And I'm going to go through and do each one of these for you. And as I do that, I'm going to review how to use this protractor to be able to do it. Now, in all honesty, I think it's easier to use the protractor in real life than it is to do it on this, but we'll make it work. Okay, so the first thing you want to do is, if you notice the center part of the protractor right here, there's kind of a crosshair where the two lines intersect. All protractors look a little different, but they all have some indication of a center piece right in the middle here. On this one, it's where the two lines intersect. I want to get that crosshair in the center of this line, and I want these edge lines along the bottom to line up with at least one part. In this particular case, it's going to line up with the whole line on the edge here. So I'm going to take this protractor and I'm going to slide it so that it lines up nicely with that line, and so that my crosshair falls in the center of that. And once I do so, I'm going to start from this right side. Protractor is set up so you can start from either side, but when possible, I like starting from the same side, usually the right. Because I'm starting at this side, I'm going to start with 0, and I'm going to keep counting from 0 until I reach the other line. So I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, all the way to 180. So that tells me that this line is 180 degrees, which you probably could recognize just by looking at it. And a 180 degree line is what's called a straight angle. Alright, let's move on to number B, or letter B, and I need to rotate my protractor so that it'll work for this angle. I'm going to use this part of the angle as my base, but again, I could use the other part, but this makes the most sense. It's facing right at me, straight forward. I'm going to line up so that my edge line lines up with that, and my crosshairs go right through what's called the vertex of the angle where the two lines meet. And once I get that exactly where I want it to be, again, I'm going to start at 0 and I'm going to keep counting until I reach. So I have 10, 20, 30, 40, 50, 60, 70, 80, 90. It lines up perfectly with 90. And so that tells me that letter B is a 90 degree or right angle. Now for C, because it's upside down, I'm going to have to spin my protractor around. And I'll use this edge up at the top for my edge, which means I need to spin my protractor a little bit more. Okay, that's not too bad. So for C, I'm going to start at 0, and I'm going to count 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and I'm a tiny bit past 110. So I'm going to say it's 111. And 111 degrees would be an obtuse angle. Okay, now we're going to move on to D. Now, as you're thinking about right angles and straight angles and obtuse and acute angles, which is the other angle we haven't gotten to yet, it should be pretty obvious to you before you even measure it whether or not an angle like this is obtuse, or in this case, this angle should jump out at you as being acute. You may not know the exact measurement of it, but you can see it's certainly not a wide angle. Okay, for this one, I'm going to get my center point, and then I'm going to rotate it so that this edge line lines up with that part of the angle. Okay, and I'm going to start at 0, 10, 20, 30. As I look at the numbers, I'm also looking at the lines. You can see at a whole number like 40 or 140, that line is long. And then there's a spot, an empty space in between 140 and 130, and between 40 and 50, where there's a line that hangs down. Well, that would be exactly the middle between whatever sets of numbers you're using. In this case, we're using the bottom set of numbers. So as I skim across, I see that this blue line, which is the angles line, doesn't quite make it to that longer line on the protractor. So if it did make it to that, it would be 35, but it looks like it's about 1 short of that. So we shall call it 34 degrees, and of course it's an acute angle. All right. If I look at E, I can see immediately that that should be an obtuse angle, certainly wider than 90 degrees. And since the bottom of that angle is a nice straight line, I think we can work off of that. So I'm going to put my crosshairs on the vertex, make sure my edge line on the protractor lines up with the bottom line on the angle. And one of the mistakes that students make when they do this is they set this hole up just like I did, and then instead of counting, they just jump over to the other line, and they'll be, oh, okay, so this is 44. Now, the mistake I just made there is I should be using the bottom numbers, but I used the top numbers because that's what my eyes were initially attracted to when I looked at the line. So it's always a good idea to start over here, make sure you start at 0, and count your way to the line. It takes a couple seconds more, but it's a good way to do it. So we have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. And it looks to be a little bit more than 140. So we'll call it 142. And of course, a 142 degree angle is an obtuse angle. Let's take the protractor. We'll move down to F. We'll line up the crosshairs on the vertex, and we'll make sure that the angle is lined up. We had it. Okay. So 0, 10, 20, and it looks to be a little tiny bit past 20. That line right there would be 20, and it's like 1 past it. So I think we'll call it 21 degrees. And 21 degrees is an acute angle. And last but not least, looking at this, you should recognize that it looks to be a right angle. A right angle can be difficult to pick because sometimes something that looks like a right angle may only be 89 degrees, or it might be 91 degrees. So it's always a good idea to measure it, but it's also a good idea to predict what you think it's going to be before you get in there. And I'm predicting that this is going to be a right angle. So I'll put my crosshair on the vertex, line up that line. I could have done it from the other way too. So we'll just have to count upside down. So starting at 0, we have 10, 20, 30, 40, 50, 60, 70, 80, 90, and that arrow lines up perfectly with the 90. So I feel pretty comfortable saying that it is a 90 degree angle or a right angle. Okay, let's move on to question number 2. Number 2 asks you to use the protractor that's already shown below and find the measure of each angle and then tell what type of angle it is. So I'm going to do 3 of these for you. We'll start with number 4. What is the measure of angle? And when you see that symbol, that means angle. What is the measure of angle ERF? A couple of things about what these letters mean. The center letter, R, is always the vertex of the angle. So when you see 3 letters, and then the center letter is going to tell you where the two lines are going to meet. So ERF, we start at E, go to R, and then go to F. So we're looking at this distance right here, the distance between F and E. So we start at 0. We're using the bottom set of numbers for this. 10, 20, 30. It doesn't quite make it to 40. It looks like it falls a little bit short. And so I think we'll call that 38. And a 38 degree angle is an acute angle. Now we're going to take a look at the measure of angle DRF. R is still our vertex. DRF. So we've got a wider angle this time. We're still starting at 0. 10, 20, 30, 40, 50, 60. And it appears to go right through that center mark between 60 and 70. So that's the halfway point. and that would be 65. And a 65-degree angle is still an acute angle. And then we have the measure of angle FRK. So we have F, we have R, we have K. So we can see starting at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. It's exactly 90 degrees, which makes it a right angle. Please use the problems that were done for you tonight to help you to solve the additional problems that are on your homework. And remember, the key to success in math is not only working hard, but working smart.